Hello, this is Mr. Taylor with Young Engineers Today. We're going to begin looking at understanding rockets using Kerbal Space Program. Alright, first, please make sure you download Kerbal Space Program. Use the demo version for your operating system. Also, yesterday we watched the SpaceX launch of a Falcon 9 rocket put into satellite. Originally it was scheduled for 5:55, but it was bumped back to 7:04 due to weather around Cape Canaveral, the Kennedy Space Center. We watched that live as well. All right, it's pretty straightforward downloading this for Mac users with a little helpful information for those who are using Windows devices. You're going to have to download this and extract all, and we recommend downloading it on your desktop. And if you follow these steps here, this will help you navigate through to your desktop and saving it to that extraction location. All right, some history. Rockets are much older technology than airplanes. Nobody knows exactly when rockets were first developed. China created the first verifiable rocket in the 1200s using the newly invented gunpowder solid propellant that realized firework explosions could be aimed towards enemies. After Newton developed his three laws of motion in the 1700s, the technology of rockets spread as a weapon for war. Fins used for stabilization were soon after created. However, other technologies prevented rocket from being a viable weapon during these times. In the early 1900s, liquid rocket propellant was discovered to be a more efficient fuel source than solid propellant. Rockets went higher than ever before and were even capable of reaching Earth's orbit. Up until modern history now, during World War II, rockets were again researched as weapon. Intercontinental ballistic missiles were developed, but just too late to be used in the war. After World War II, the Soviet Union launched a rocket to go into Earth's orbit. Soon after, they launched the first orbiting satellite and then the first surviving creature, a dog, as you can see in the image. This paved the way for the space race between the U.S. and Soviet Union in the 50s, 60s, and started the formation of NASA and put a man on the moon. Now, Newton's laws. His first law, object at rest tends to stay at rest, and object in motion tends to stay in motion unless an external force is applied to it. This law is the law of inertia, Newton's first law. Think of a rocket sitting on a launch pad. Will it launch without its engines being throttled up? Of course not. Though it may not seem this way, the engines are an external force which allows its vertical movement using a force called thrust. Then why is it so difficult to get into space? Other external forces are pushing against the rocket. Many forces, like air resistance and the rocket's own weight, are preventing the rocket from escaping the Earth's atmosphere. Rocket engines must produce an amount of thrust which is greater than the force pushing against it. It takes a lot of thrust to overcome such forces, which is why rockets must be so powerful. Newton's second law, force equals mass times acceleration. Weight is a force, but gravity is not a force. It's an acceleration. For example, your weight is your mass multiplied by the acceleration caused by the Earth's gravity. Rockets are the same way. They have weight caused by their mass and Earth's gravitational acceleration. These forces act through a rocket's center of mass, the point at which the mass is distributed evenly through the rocket. To display force, scientists use pictures called free body diagrams. An object at rest like the rocket on the launch pad pictured in the free body diagram on the right has only two forces acting on the center of mass, weight and normal force. The constant normal force, yet another one of Newton's laws of motion. Newton's third law. For every action, there exists an equal and opposite reaction. To understand this law, push your hand against the tabletop. Your hand is exerting a force upon the table, but the table is also exerting a force upon your hand. This force is normal force, and it is the reason your hand doesn't simply pass through the table. This is also why we don't fall through the Earth towards the next closest center of gravity, which is our sun. Now, open up Kerbal from the folder on your computer. Now that you know the base behind rockets, since the orbiting mechanics, you can open up Kerbal Space Program Demo. It is the KSP file on your desktop or where else you saved it at. You will select Start Game, select Start New. Note your player name is Demo. Select Game Mode, Sandbox, and select Start. Now, a few things. Select the vehicle assembly building located in the center of your screen. I'm actually circling my cursor around it. On the upper left-hand corner of the game screen, select Command Pod MK1, which is right over here. This is the payload of the rocket, which includes your space for your Kerbal pilot and the scientific tools and instruments. Next, the payload. In the upper left corner, select the tab labeled Utility. If you hold your cursor over anything, it will tell you what it's called. The utility looks like an atom with a nucleus and the rings showing electrons. From the list selected MK16 parachute. This parachute will help keep your Kerbals alive when trying to land after a mission and make your rocket aerodynamic during launch. The parachute will follow your mouse, so place it on top of the command pod. When it's red, it's not attached. When you attach it, it will turn green. Now, off to the right, you have some images that will show your stages of your rocket. We'll be getting into this a little bit more shortly. All right, a decoupling device. Decoupler is the middle tab out of the center of all the tabs on the left. For structural tab, and select the TR-18A stack decoupler. Anything placed below the decoupler can be jettisoned during the mission. Place a decoupler in the bottom of the command pod. This is so you can detach any parts afterwards, so they're not directly attached to the pod. Propulsion. Now scroll to the propulsion tab in the upper left-hand corner. Select the RT-10 solid fuel booster. This booster contains both solid rocket fuel and the engine in one device. All right. We're going to be looking at the difference between solid propulsion and liquid propulsion. All right, solid propulsion uses a solid propellant, cannot be stopped or slowed once activated, simple to use. Liquid propulsion uses a liquid propellant. Throttle can be controlled, amount of gases flowing can be increased, slowed, or even stopped. More complex to use than solid. We're going to be flying with both rockets so you can see the differences. Stages, note that adding this propulsion element adds an extra stage to your rocket, which you can see in the bottom right hand corner. At this point, there are two stages in the rocket. They count down from highest to lowest. Note, stage 1, your payload is not included as an active stage, hence stage 0. All right, instruments. Select launch on the upper right hand corner. Your rocket is placed on the launch pad. Your screen will have several instruments scattered. Next few slides will show that. Top is your timer and warp. Timer is your T plus or your T minus countdown. In this case, it's T plus. Warp allows you to speed up real time or slow down real time. Altimeter tells your elevation. Your vertical speedometer is showing your vertical speed, your atmospheric density, which can be used for drag and determining where in the atmosphere you're at. Down in the bottom left corner, you have your rocket stages. Then you have your control surfaces, your roll, your pitch, and your yaw. Then the far right, you have your pilot. And then in the middle, starting from left to right, you have your throttle, your surface speed, your G-force meter, and your nav ball. Okay, well, let's go into this a little bit more. Altimeter shows your height. Your vertical speed shows your velocity as you fly through the atmosphere. Atmospheric density shows thickness of the atmosphere surrounding the rocket. Good for estimating drag. Your mission elapsed time shows how much time has elapsed since liftoff. Warp shows and gives you the ability to speed up or slow down the passage of time. This is used for conducting long missions. Stages show active and remaining stages of your rocket. Roll, pitch, and yaw shows the orientation of your rocket compared to its original configuration on launch pad. Orbit map shows a map of space, including trajectory after liftoff and other interstellar objects. All right. Now, when you click on that map, you can see the planet Kerbal, and if you look down on the left-hand corner, you can change your views. All right, last thing from instruments, your nav ball, which is critical for moving your rocket on the ground. The gold arrow should be perfectly aligned with the horizon, but will change based on your position in the air. Your surface orbit speed shows your velocity relative to your surface of a planet or your speed when in orbit around a planet. Don't worry about the other buttons I didn't discuss yet. We'll get back to those. Okay, when launching, to launch your rocket, hit your space bar. Your rocket will send straight up. Watch the altimeter, top, center, and surface speed bottom. You can control the angle of the rocket by using WASD keys on your keyboard. While your fuel burns, experiment with moving your rocket. See how the nav ball responds to the movement. Your rocket has a finite amount of fuel, and you can watch it deplete in the bottom left-hand corner. As soon as the status bar reaches empty, your rocket will stop accelerating, but you will still continue ascending. Momentum. Hit your spacebar once to jettison the rocket booster and engine as you no longer can use them. This is why we use the decoupler. Watch your altimeter until you begin to descend. At this point, hit your spacebar again to deploy parachute. At this point, feel free to use the time warp to land quickly. Use this until you reach 1,000 meters. At 1,000 meters, return to normal speed, or else your parachute may rip off. Once you've landed, you've completed your first successful mission. So go ahead and try this. Pause this and go and have some fun with this. And make some observations. All right. Now, we're going to switch out from solid propellant to liquid. You're going to hit escape on your keyboard, select end flight, and select vehicle assembly building. Remove the previous solid rocket booster by selecting it and hitting delete. Replace the fuel tank by selecting propulsion in the upper left corner. Click on the FLT. I believe it's either 400 or 200, whatever you have there. Then this is only a fuel tank, so you're going to need an engine as well. So we're going to select an LV, whatever you have, and place it on the bottom of your rocket. Okay. Now, prediction. How will this rocket behave differently than the previous one? You'll be able to control the throttle and thus control the speed of your rocket. Think about going back to what we talked about, the difference between liquid and solid. We can control the flow or speed with liquid versus solid. Once you start the ignition, that's it. You'll have to start paying more attention to your rocket behavior. Now, select launch and go to your launch pad. To launch, you will need to increase your throttle 100%. Hit lift dash shift. The shift button on the left shift button, is under your cap lock button and on your keyboard, and max the throttle, hit your space bar. You may notice your rocket starting to veer off to one side. To control the orientation of the rocket, you can select your WAS or D keys. Try to keep your nose perfectly upward by altering your rotation, like shown in the picture, and see how high you can go. Thank you. This is our first introduction into using Kerbal space program. This is Mr. Taylor with Young Engineers Today. Thank you and have a great day.